Hello friends, welcome to this video. So here in this class, we will discuss about another numerical problem which was asked in JEE 2021. Okay, so it was also asked in JEE 21. In other earlier two videos also we discussed numerical problems that were asked in the same examination. So let us first read the question and then we will discuss about its solution. So the question is the coefficient of static friction between a wooden block of mass, okay, the mass of the wooden block is given to be 0.5 kg and a vertical rough wall is 0.2, okay. So this is the coefficient of static friction. Now what will be the magnitude of the horizontal force that should be applied on the block to keep it adhere to the wall? Okay, so you have a block. Okay, so okay, maybe my drawing is not that good, but I will make you understand the question. So you have a block, okay, wooden block which has got a mass of 0.5 kg. So rough wall, okay, there is a vertical rough wall, okay. So this is a wall, okay, this is a wall, rough wall whose static friction coefficient is given to be 0.2. So now what magnitude of horizontal force should be applied, okay? Horizontal force, suppose this is a horizontal force, maybe this force is represented by F, okay? So what would be the magnitude of this horizontal force F so that the block does not fall down, the block remains adhered to the wall, okay? So let us solve this question. I will solve this question in my electronic board. So, okay. So let me draw the picture again. So we have a block, okay? We have a block and we have a wall, okay? This is a wall. The wall is a rough wall. It has got coefficient of friction, static friction, which is 0.2, okay? This is 0.2. The mass of this block is given to be 0.5 kg, okay? And acceleration due to gravity g value, let us assume that the acceleration due to gravity is 10 meter per second square, okay? So the question now is how much force should be applied horizontally so that this block does not slide down or the block does not fall on the floor, okay? Maybe this is the floor and the block does not fall. Okay, let us analyze the scenario. So this block has a weight, okay? The weight of the block will act downward, okay? The weight is given by mg, mass multiplied by the acceleration due to gravity, okay? So we have to balance this block. So this friction force, okay, the friction force, friction force acts in a direction opposite to the direction of motion. If we had just let this block fall, so it would fall below, okay, downward, so friction force would act upward. So let us assume that the friction force is suppose Fs, okay. Sorry, let me do one correction here. So coefficient of friction is not given by Fs. Suppose the coefficient of static friction is given by mu s, okay. So Fs is the friction force itself and mu s is the coefficient of friction, okay. So ideally the balance should be, okay, the balance between these two forces, the friction force and the weight in this scenario would be Fs is equal to mg, okay. So the friction force is equal to the weight of the block, wooden block, okay. So now suppose let us consider that there is a force, some type of normal force, okay. So this normal force would be the force which this block would exert on the opposite force F, okay. So because the wall, okay, because a force would be applied on the block, so this wall itself would apply a force in the opposite direction on the block. Okay, that force should be opposite to the this force, opposite to the force capital F. Now, according to formula, this friction force is given numerically as the coefficient of static friction multiplied by the normal force. Okay, so friction force F S is equal to coefficient of friction multiplied by the normal force. I hope all of you know this formula. So let us substitute the values. The mass of the block is given to be 0.5 and the acceleration due to gravity is given to be 10. Okay. So what would be the normal force? The normal force would be 0.5 multiplied by 10 divided by mu s. Okay. So 0.5 multiplied by 5 is equal to 5. Okay. So Newton. This is Newton. Newton would be the unit of the normal force. Okay. So mu s is given to be simply 0.2 already given. So 0.5 divided by 0.2 Newton. So how much value would we get? So the value of n would be, here. So it will be 50 divided by 2, which will be 25 Newton. Okay. The value of n would be 25 Newton. So you see here, n is opposite to this force F. Therefore, F is equal to n is equal to 25 Newton. So we must apply a force of 25 Newton on this block so that this block does not slide, okay, and it remains adhered to the wall. So I hope you have understood the solution of this problem. Just to make this force of friction equal to the weight, okay, and use the formula force of friction, this formula, and you substitute the values, and thereby we can calculate the normal force which acts in a direction opposite to the applied force, but they are equal. Okay, the normal force is equal to the applied force, and we can eventually calculate the value of the normal force. So the force is equal to 25 Newton. So this much force will be required to make the wooden block adhere to the wall. So I hope you have understood this solution. If you understood the solution and like the video, please like it, subscribe to the channel and share it. Thank you very much for watching, and we will see in the next video. So thank you very much.